Okay, so this is number 14. So one side of the equilateral triangle is height 24 lies on a line L, and a circle of radius 12 is tangent to that line L and external tangent to the triangle. So the area of the region exterior to the triangle and to the circle and bounded by the triangle, circle, and that line, it can be written in this form. We want to find the sum of those ABCs. Okay, the question looks interesting, but make sure you really understand what's going on. Like first, like we are told there is a equilateral triangle and then there is a line it going through one of the sides. The line L is going to be just a line goes through one of the sides. And then there is a circle. The circle is going to be tangent to that line as well as a triangle, but outside of the triangle. So with radius of 12 and the height of the triangle is given. So let me try something visual. So let's say this is my circle, and then we want to have a line that is tangent to the circle. And also we have to have a equilateral triangle where one of the sides should be on this line. Okay, so let's try something like this. And then our equilateral triangle should be tangent to the circle as well. So it doesn't have to be accurate, but at least it does look like this might work. Okay, so imagine this is the case, right? So we have a circle, radius of 12, and then we have a equilateral triangle that has a height of 24. So let's drop the altitude. And then we know we are talking about the circle, so we have to connect the center to the tangent C. So this is one, and then this is another tangent point. So we can connect those. So this is 12. This is 12. This is 90. So, and then this is 24. And then we know this is 60. And this is 30. So we by the 30, 60, 90, so the 60 degrees is opposite to x root 3. If you divide 24 by root 3, so you will get 8 root 3, right? So 8 root 3 for this part. So 8 root 3 is this part. Okay, so now we need to know the area of the region that is right here. Okay, this is the region that we are interested in. Okay, so to do so, like we can probably find the area of this sector right here and subtract this region, but finding the area of sector doesn't look like helpful. But if I connect this point to this point, I will get a triangle, which is not just right in a triangle, it's just actual right triangle because this is the tangency point. So if I find the area of the triangle and subtract the sector, so we can actually end up getting what we want. So let me share this as well. So if I'm gonna color in this in yellow, this is the sector I'm gonna subtract from the area of the triangle. So we know that the angle right here is 90. Since we know this is 60, the interior should be 120, and this triangle are identical. So that will be 60 and 60. That means this is 30 degrees. So like we have something like this. Okay, so imagine this is your triangle right here. So we have, this is 12, and then we know this is 60, and then this is 30. So 60 is opposite to 12. So if we divide this by root 3, so you get 4 root 3 for this side. So that basically equal to this part. So now we are gonna find this shaded region, but just this small piece, which is half of what we are looking. So it's gonna be area of the triangle, which is 12 times 4 root 3 over 2 minus area of this sector. So since this sector has 30 degrees, so that should be like 1 over 6 times pi times radius squared, which is 12 squared. But when you do this subtraction, you just get this region, which is only one of them. And then I need to multiply this by 2 to get our entire region that we are interested. Cancel these two, so that should be 48 root 3. So like you can write this 12 times 12. So 6 and one of those 12 will cancel. You got 2 times 12, which is 24 pi. And then you got 2 times, that will be, let's see, 2 times 24, which is going to be minus 48. So if I'm not mistaken, let me double check. We got that. So 12 squared, that's going to cancel 24 pi. So 24 pi, 48 pi. Okay, so it looks like we have this. So to cancel this, that's going to be 48. So I think we have the answer 48, 48, 96 plus this will be 101. So no trace like that. So there is something went wrong. Let me double check. So the radius was 12. The height was 12. Okay, that's going to be divided by root 3, which is 8 root 3. That looks good. And then we know this is 8 root 3, but we kind of didn't use that information at all. And we know this is radius 12. And then this was 60, 60, 60, 30. So that should be 60 divided by root 3. So 4 root 3. So that looks good. And then we have 12 times 4 root 3 over 2. That's the area of one triangle. Subtract 1, 6. Oh, this is actually 30 over 360, which is 1 over 12. So this was 1 over 12. So that means this is going to be 24 pi. Okay, so I kind of mess with that. So that will be 24 pi. So we are looking for the answer ABC. A is like 48, B is 3, C is 24. So if you add these, you got 72 plus 3 is 75. Okay, so that was an interesting problem, but actually this wasn't too challenging, but making this like visual might be a bit struggle, but I think that's reasonable for number 14. Anyway, so let's see another question.